Hello, this lesson is on topic 2.12, problem solving. Today, together, we're going to solve application problems involving both whole numbers and fractions. You can see that there's a chart about all the different operations and words that can signal those operations. Definitely words like sum, difference, product, quotient are words that we need to know. But there's also some words here that can become confusing. Words like per. Sometimes per can mean multiplication if we don't know the total. For example, if we're earning $15 per hour for 3 hours. But per can also mean division. So when there's a split or a divide of something, when we have a total $80 per 4 hours worked, then we're going to be dividing 80 by 4 to get to 20. So this page can help you quite a bit, but sometimes word problems don't have keywords. So we take each word problem case by case. For this lesson, I'm going to solve every problem in the exercise. So what you can do is pause, work through the word problem, try it on your own, and then you can watch the video of the solution for the questions that you feel you need. So number 1, salesman takes a business trip and travels the following number of kilometers each day. On Monday, he travels 385 kilometers, Tuesday, 412 kilometers, Wednesday, 394, Thursday, 403, and Friday, 431. Find the total kilometers traveled for the week. So because the question's asking us for the total, we're going to be adding all of these days because each day is different. So we're going to take 385, 412, 394, 403, and 431. Now there's so many ways that we can add these numbers. You can add them in groupings of 2 or 3 and then add on a couple more. I chose to put all 5 of them together and add all of the numbers in the ones place, tens place, and hundreds place at once. So 5 plus 2 is 7, plus 4 is 11, plus 3 is 14, and 1 more is 15. So I'm going to carry my 1 up high. 8 plus 1 and another 1 makes 10, plus 9 is 19, and 3 more makes 22. 2 plus 3 is 5, plus 4 is 9, plus 3 is 12, plus 4 is 16, and plus 4 more is 20. So in total, he traveled 2,025 kilometers in that week. For number 2, Mary has volunteered to bake desserts for her school bake sale. She baked 2 dozen cupcakes and plans to sell them for $3 each. She also baked a dozen brownies and will sell them for $2 each. How much money will Mary raise if she sells all her baked goods? So here we have 2 dozen. So a dozen is 12, so 2 dozen is going to be 24 cupcakes. And then she baked a dozen brownies. So we're going to take the cupcakes first, the 24, and multiply by $3, plus the brownies, which is 12, multiplied by $2. We don't need to include the decimals when we do our calculation because we know that it's not going to have any change. So we can take 24 times 3, which is 72, plus 12 times 2, which is 24. And then we can add 72 plus 24 to see the amount of money she will earn. So we will have 6 and 9, so $96 is what she's going to raise. We can show this with the cents, or it's not really necessary to, but the dollar sign definitely is. So she will raise $96. Number 3, in the month of June, the Anderson family made 4 bank deposits of $1,782 each. So they made 4 of those. They also withdrew $5,931 for expenses. What was the account balance for the month of June, assuming that the Andersons had nothing in the account at the start of the month? So we're starting from 0. So let's first calculate the deposits. We know deposits means positive numbers. So we're going to say 1,782. And there's 4 of those. So let's determine what that is first. 1,782 times 4. 4 times 2 is 8. 4 times 8 is 32. 4 times 7 is 28. Plus 3 is 31. And 4 times 1 is 4, plus 3 is 7. So 7,128 deposited. But then they made a withdrawal. So our first step is to calculate the total deposits. Our second step is to calculate the withdrawal. So we start now with 7,128 and take away those expenses. 7,128 minus 5,931. 8 minus 1 is 7. 2 minus 3 we must borrow. 12 minus 3 is 9. 0 minus 9 we must borrow again. 10 minus 9 is 1, and 6 minus 5 is 1. So what was their balance? Their balance was $1,197. Balance was $1,197. Number 4, a group of 6 foreign language students is planning a summer trip to Germany. The total cost of all 6 flights is $8,400. Each person will pay $600 for hotel fees. If the 6 students pay equally for the flight, what is the cost of the entire trip for each student, including the hotel fees? All right, well, we know the total for 6 flights, and we know the amount that each person has to pay for their hotel. And we know that there's 6 people. So our first step is to divide up the flight cost to get back to the individual cost. So we're going to take 8,400 and divide by 6. So 6 is our divisor, 8,400 is our dividend, and we can begin to divide. 6 goes into 8 once. 1 times 6 is 6, and we subtract. 8 minus 6 is 2, and we bring down the 4. 6 goes into 24 4 times. 4 times 6 is 24. And we subtract and we get to 0. And at this point, we are done because we can bring down zeros, and in our quotient, we're going to fill up zeros. So the cost per student for the flight is $1,400. But remember, they had an additional cost, which was the hotel, and our question asks us to include the hotel. So our second step here is to take the cost of the flight plus the cost of the hotel per person. And 1,400 plus 600 equals an even $2,000. So the total cost is $2,000 per person. Number 5, on Sunday, June 21st at 5 o'clock, the temperature was 27 degrees. The temperature dropped 2 degrees per day over the next 7 days. What was the temperature on June 28th? So here we have a drop in temperature. So we're going to see a negative value here. And that's each and every day for 7 days. So we have a repeated drop. So our first step is to determine what that temperature change will be over 7 days. So we're going to take a -2 multiply that by 7 days to get a total drop of 14 degrees. And we know that on June 21st, we started at 27 degrees. So we are going to take 27 degrees and we're going to subtract the 14 degrees, showing that drop. And this is degrees Celsius. Additionally, we can show this as a plus a negative. So if you see, if I subtract, I can add the opposite. So I can also add a negative 14 degrees Celsius. We know the temperature is going down, so we can express this in both of these ways. So 27 minus 14 will still result in a positive temperature, 13 degrees. But on June 28th, the temperature was 13 degrees. Number 6, in the ice tower, the temperature drops 4 degrees for every floor the elevator goes up from the basement. So we see a drop of 4 degrees. What is the temperature on the 12th floor if the temperature in the basement is 20 degrees? Okay, well, first up, we need to know how many floors that is. One way we can determine this for sure is to kind of make a visual. So if we go basement to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, and we count up, we can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So truly from the basement up to the 12th floor is a change of 12 floors. Sometimes we can be fooled into thinking that's 13 floors going from the basement up to 12, but it is in fact 12 floors. So we are going to take the 12 floors that we're traveling, and every single floor is dropping 4 degrees. So we have repeated action here. So each floor is dropping 4 degrees, so it's a multiplication question. We're going to multiply to see how much in total that temperature has dropped. 12 times 4 is 48. So we see that the temperature has dropped 48 degrees Celsius. But luckily we didn't start at 0. So our first step was to determine the total drop, and our second step is to say, okay, we started at 20 and then we went dropping down 48 degrees. And we can show this as adding the opposite because we have 20 minus 48, or we can show it as 20 plus the negative 48. Either way, we're going to end up with a negative temperature, and we're going to subtract 48 minus 20, which gives us 28 degrees, and that's a negative 28 degrees Celsius. So the temperature on the 12th floor is negative 28 degrees Celsius. Number 7, Sam bought 250 shares of a stock. The price of the stock fell $3.03, so 3 3/5 of a dollar. How much money did Sam lose? Well, every single stock fell 3 3/5 of a dollar. And he didn't just have one stock, he had 250 of them. So we're going to see a negative value of money multiplied by every single one of these shares. So we can take 250 of those shares and multiply by a negative 3 3/5. And you can have it switched around as well, it doesn't matter. We're going to be multiplying a positive times a negative, so we'll end up with a negative result. But we have fraction here, mixed numbers. So what we need to do is put 250 over 1, make that into an improper fraction. And then we're going to multiply by 3 3/5, change to an improper fraction. So 5 times 3 is 15, plus 3 is 18, so it's going to be a negative 18/5. And we can do some cross-reducing here. So we have 5 and 250. Well, we can divide by 5, and 25 divided by 5 is 5. And then we just got to bring that 0 along. So we're going to have 50 there. Now we have some bigger numbers to multiply. We have 50 times 18. So I'm going to switch this around and put my 50 on the bottom. That way I can bring this 0 down and go right to the 5. 5 times 8 is 40. And 5 times 1 is 5, plus 4 is 9. So unfortunately for Sam, he lost $900. Sam lost $900 on those stocks. Number 8, a waitress earns per hour $11.25. How many hours will she have to work to earn $180? Okay, well, we know the goal. Her goal or total is 180. So if we multiply, we're just going to get bigger than that. So this is a division question. Every hour is the same. We want to meet that goal, so we're going to divide $180 divided by her hourly wage to get the total number of hours. We know with division of fractions, we're going to change to multiplication. We also know that we need to have improper fractions. So I'm going to make 180 over 1. I'm going to write the division and change 11.25 to 45/4. And then I'm going to keep, change, and flip. So 180 over 1 times 4/45. Now we have some big numbers here without a calculator, but we can do it. Let's start to cross reduce and see where we end up. So I have 45 and 180. I can look at 180 like 18 and then 45. So I know 5 doesn't go into 18, so I might not go that small, but I know 9 goes into 18 and 45. So I'm going to divide by 9 first and see where I end up. So I'm going to divide by 9 and divide by 9 here. Now 18 divided by 9 is 2, and then we bring the 0, so that's going to get us to 20. And I can see here that I could have gone bigger because I have 20 and 5 left. So I'm going to divide by 5 now. Divide by 5, and 20 divided by 5 is 4. In our denominator we have a 1 times 1, so we're going to just leave that denominator off. And in the numerator we have 4 times 4. So she needs to work 16 hours in total to reach that goal of $180. Number 9, how many quarter-minute TV commercials could be shown in the 3-minute time period between 10:57 and 11 o'clock? All right, well, we have 3 minutes maximum to work with. And in that 3 minutes, we're going to be showing as many commercials as we can. So we're going to be splitting up that 3 minutes into chunks of time, with each chunk of time being the exact same. So because we're splitting up that 3-minute time period, we're going to be dividing. So we need to put the 3 first, and we're going to divide that up by 1/4. We have a fraction here, so we're going to change the 3 to be 3 over 1. And because it's division, we're going to keep the 3 over 1, change to multiplication, and flip to the reciprocal. Now we have multiplication. 3 times 4 is 12. So we can have 12 commercials in that 3-minute time period. I hope you found this video helpful.